How are you doing today? Got another part for the podcast, and this is actually part four. This is the final part, and he's actually talking about his manufacturing process, what problems they may run into, and getting these Apteras into the hands of the people. And actually, he also talks about you know how they're going to set everything up manufacturing wise. So yeah, let's go ahead and talk about that. We'll listen to it and then we'll talk about it at the end.
My mind can't find the words, no, I can't seem to find. I don't really try to get reason, rhyme, and take your time and choose whether we green or yellow, whether we deep or shallow. Please, we know, 'cause we're about to lose, whether we buy or hello, whether we stay or jello.
You're listening to A Climate Change, and I've got Steve Fambro, CEO of Aptera. Steve, exciting times for you and the company. How many people are currently working for the company, and how many people are you going to need as the company goes into production of the vehicles?
Here in the U.S., we have about 100 folks under our roof between our solar facility just a couple miles down the road and here at the headquarters. Overseas, mostly in Italy, we have probably another 20 to 30 people, maybe 50 or so through various vendors that we're working with. So suspension, lighting, aluminum castings, that kind of thing. To get the vehicle in production, the team in Italy will grow by about 30 folks. And our team here will grow a little bit less than that for the final assembly, because we're going to be doing the body assembly in Italy first, shipping the bodies over here, probably with the suspension and wheels on it, where we'll put on the glass, we'll put on the solar panels and that kind of thing. That final balance of what we're going to do in Italy versus what we're doing in California hasn't been decided yet. But our original plan had us only hiring about 40 people for the factory here. It's going to be a little bit less than that. At a 12-minute tack time and 40 vehicles a day, it's just, there's not a lot of people that are needed. Most of the engineering will increase for validation, testing, et cetera. Some of that will be outsourced through our partners that do that kind of work, Roush, et cetera. But some of those engineers will be full-time in-house. So you're probably going to see that climb up to about 300. And if you tell that to anyone in the automotive or startup electric vehicle industry, they'll laugh. They'll say, "There's no way you can do it with that. It's so small." But again, we're not building a traditional car. We're building a much simpler vehicle. It has fewer parts. A lot of our partners are validating these various systems for us. So there's much less work that we have to do than a typical company who says, I don't want to. There's other EV companies who maybe they've hired thousands, tens of thousands of people to do all of these tasks in-house. We just don't have to do that. We have competent partners that can do that, some of that stuff better than we can, and we leverage that.
So in terms of vehicle production, you had said 40 vehicles per day. I was just doing the math. That's about, 1,200 vehicles a month, 14,000 vehicles a year. Is that your target? Where do you see this going in the future?
It's 40 vehicles a day per shift for this building. The decision, and what that gives us is it gives us a starting framework that we can demonstrate here and then either copy or scale. It remains to be seen based on all the different economic variables of energy, labor, everything else. If the optimum assembly for this vehicle is 2 or 3 facilities around the United States or one big facility somewhere, central or on the East Coast. That calculus isn't clear to me yet, which one of those are better. I know the way the industry goes. The industry goes for a single facility, and they do that because it's highly capitalized, and they can't afford to distribute, to copy that capitalization everywhere. But our vehicle doesn't have that. It's assembled very differently. I think about it, when the parts come in from the suppliers, it's almost like taking flat packs of IKEA furniture and just deciding where you're going to put it together. You probably want to put it together really close to where you're going to use it, like in your living room or in your kitchen or wherever. You don't want to put it together some distance away and ship that product to there. So that is our strategy, is to have the subassemblies kitted and packaged from the vendors so that we can literally bolt this thing together anywhere in the world. And there's all kinds of advantages and reasons why you'd want to do that. Not the least of which are tax advantages, depending upon the country that you're either building in or importing into, et cetera.
That is fascinating, because that is truly revolutionary to put together kind of a car like a piece of IKEA furniture. I realize you're simplifying it quite a bit, but still, it's to stand up a manufacturing facility of a vehicle is usually a multi-billion-dollar equation, and to do it for far, far less than that is revolutionary. It's expending a hell of a lot less in resources, and if we're talking about sustainability, that goes a long way. As we were kind of discussing, one of the things kind of off air was using less of this carbon fiber than you would of steel, because it is stronger, so at a magnitude of 2, 3, 4 times stronger. So you using less material as well in making the vehicle.
That's right, and I think that's most engineers, most companies that make products to engineer a product. They really only want to use the amount of material or the amount of stuff that's necessary. They don't want to overdo it. Nobody does. But in our case, we could have made our original Alpha vehicles that you've seen driving around. Those are 100% structural composites. So there's no steel or metal coming from front to back in the vehicle. It's just the entire composite structure carries loads. And there's pluses and minuses of that. There's reasons, why you'd want to do that or you wouldn't. In our case, what we found is, although we could make a technically lighter part with our sandwich core process, I mentioned to you earlier, it wouldn't scale. That's a big reason. The second thing is that you can't accurately model it in a finite element analysis. You can kind of model it, but because the material is discontinuous, use an engineering term, you've got these sort of hard interfaces of fiber and resin, and then a core, and those are all discontinuous. Those are all they call edge effects in finite element analysis, and it's very difficult to model that. So what it means is you have to do a lot of destructive testing to characterize a part, and companies do that all the time. But the advantage of going with CPC is that their material is homogeneous, and so it's well characterized. It's isotropic. It has the same reactive nature with force in any direction, as opposed to a composite panel, which is stronger in one direction versus the other. So we give up some of that weight benefit to have something that can be modeled easily. And that lets us really fine tune and reduce the amount of materials that's needed. And then we can start playing little games where you say, well, what if we make the battery pack structural, and instead of having that structure in the carbon, then we can make the carbon tub thinner and make it cost less, because that was the most expensive part of the materials. So we've used aluminum. We have castings that sort of connect the vehicle and the structural battery pack together. And we've been able to do that to lower the amount of carbon that we make the vehicle out of, to lower the overall cost. We could make more. We could make it out of more carbon and get rid of the aluminum, but it'd be a little bit higher cost, and we don't want to do that. So we're trying to have the optimum of performance, weight, and also cost. And this material and CPC in their process lets us do that in a way that we could not do it with sandwich core composites. Compared to
sorry to interrupt you, Steve, but tell us about the three main objectives of the company over the next 3 to 12 months as to the challenges you face to kind of get the vehicles out the door and into the hands of the public.
The three big milestones, I would say, are wrap up our Series B fundraising, begin kicking off some of the high expense tools, both for the body and the motor. We've got to get in the order queue for some of the battery welding robots. So we close a round of funding, we can make all those orders, and then start getting body panels off the tools about mid-year to July maybe. And then once we're getting body panels off of the tools, we will have already had our castings and all that other stuff done. We can start testing the vehicle, sort of privately, not in the public, but doing the brake validation, crash testing, that kind of thing, because we'll have a manufacturing representative product, structure, body that's made off of production tools, made with production processes, and that's what we can characterize and validate. So I would say wrap up the Series B, place the big purchase orders that we're waiting to do, and then start getting body panels off the tooling about mid-year, July, sometime that time frame, so that we can start doing some of the final validation.
So how much are these high expense tools that you're buying?
Oh, not as much as a regular car company, but a battery, let's say an ultrasonic welder for the battery cells is about $250,000 a piece, and the best companies in the world that make them are German, and so and everybody wants them, and so there's a queue. And we need several of those. I say several, I mean a little bit cheeky, more, probably 10. But that gives us the ability to make 40 packs a day per shift. All of these tools also can run multiple shifts, so that the 40 a day really comes from one shift. So the easiest way for us to scale is simply to start a second shift, because the tooling that's why car companies have 2 and 3 shifts, just so they get maximum return on that capital equipment.
Right.
So by going into a second shift, we'll double the output.
Right. So you could maybe take the 30,000 and then maybe 45,000 cars per year, which would be great. Well, Steve, great talking with you. Steve, running the car company, Aptera. Steve Fambro, thanks for being on the show. It's been a pleasure. And
Well, as you can see, I'm ending it right there. That was the very end of it. And Steve brought out a lot of good things. You can see that he is actually moving forward. He has a plan in place, and he always delivers on what he promises. So we can put full faith in what he's going to do is going to happen. So he's bringing out that actually they're going to start producing 40 vehicles a week, and they can actually ramp that up if they need to. The factory that they're going to be building at is pretty small, so they can upgrade it with no problem, and they can place them just about anywhere at no problem. And he's also expecting to get the bodies from the CCP in July. Hopefully it'll be sooner than that, but oh gosh, look how beautiful that is. And so he's going to start crash testing it and get all the information from the solar panels and the range and all that. So we'll be updated with that. But this car, look how beautiful that is. How could you not want that? And I mean, if you invest in this, I am not a financial advisor, so you might want to consult with your financial advisor and ask him about investing in Aptera. But even if you don't invest in it, you could still buy one. And I got a link below that'll take $30 off. So all you have to do is put down $70 to get you one of these. This is an awesome vehicle. This is really going to change everything. Oh, I'm so glad I'm a part of this. And all those that have been waiting, I know they can't wait to get their hands on this, just like me. And so, I mean, we have formed a little close-knit community here, the Aptera family. You could be a part of it. Either join or get you one. And then you can have this beautiful Delta vehicle. Oh my goodness. Well, it's not the Delta, it's an Aptera. But still, I'm just so excited. I can't even talk straight. I'm so excited. So yes, go ahead and do that. Get it done. Shout out to my Patreons. You guys are awesome. Oh man, you guys make my day. Continue to support my channel, and I'll continue to come out with the latest video and update you as soon as I can. You guys are great. You guys have a good day. Enjoy the rest of it, and we will talk to you in the next video. All right, you have a good one. Bye-bye.